everyone. Welcome to the Multi-Cloud Security Summit. Today's event, organized by the hardworking folks at Virtualization and Cloud Review and Redmond Magazine. We have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, VMware, one of the world's leading providers of virtualization and cloud computing solutions and services, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of 3 information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsor, VMware, has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. As you leave today, you'll be asked to take a very short survey. Please take a moment to share your honest opinions. Our editors read every comment, and they help to shape our future events. And last but not least, at the end of the 3rd session, one lucky attendee will be receiving a Surface Pro 7, Microsoft's ultralight tablet featuring a laptop-class Intel Core processor, all-day battery, and HD cameras. But you must be present to win, so stick with us. Now let's get started with our first session, Top Hybrid/Multi-Cloud Security Threats. For this session, we've called on Ian Thornton-Trump, Chief Information Security Officer at Cyjax. Ian is an ITIL-certified technology professional with 25 years' experience in IT and cybersecurity. From 1989 to 1992, he served in the military intelligence branch of the Canadian Forces. In 2002, he joined the Canadian Forces Military Police Reserves, and in 2013, retired as a public affairs officer. After a year with the RCMP as a criminal intelligence analyst, he worked as a cybersecurity analyst and consultant for multinational insurance, banking, and regional healthcare organizations. Needless to say, Ian has a great depth of experience with the threats facing small, medium, and large enterprises today. His experience and ongoing research have made him a sought-after cybersecurity consultant. He also teaches cybersecurity and IT business courses for CompTIA as part of its global faculty, and is the lead architect for Cyber Titan, Canada's effort to encourage the next generation of cyber professionals. I know you guys are in for a great session. Take it away, Ian.
Thank you so much, John. It's just my absolute pleasure to be here. And I am blessed today to have 2 wingmen, which are application security specialists. And Mike Thompson and Sean Wright-Seck are going to see us through as escorts on this presentation. Because when I was asked to do this, I thought long and hard about where the threat really is and how it manifests itself. Now, I'd be remiss in saying, and gentlemen, please jump in at any point when you have a point to make on this presentation throughout it. And we have an amazing story about how this presentation came together at the end during the Q&A session. But I would be remiss in not suggesting that you tune in for BeerCon 3, the 3rd conference put together by the beer farmers, of which Sean, Mike, myself, and a couple of others are members. And we will have 2 days of speaking and events for you. Now, to frame this whole kind of debate and understanding, there was a lot of choices that we needed to make in terms to set the stage for what we're going to be talking about. So what we're not going to be really talking about is the malicious actors that are going to target and attack your organization. What we are going to be talking about is the mistakes and confusion around multi-hybrided environments and multi-cloud. So one of the first things when I was researching this topic is I really had to get my mind around what do we mean by hybrid? And there was a lot of confusion about that meaning. And then, of course, in discussions with Mike and Sean, we talked about architecture. And architecture is another almost trigger word that we have because we're not really sure what it means. So this is a hybrid from the Expanse. And again, because, I could have put a picture of a Toyota Prius there, also a hybrid. But what we really are going to do is set the stage right here about what is hybrid cloud and multi-cloud. And this is where I think we can all agree, for the context of the discussion that we're going to have, is that we are dealing with a type of cloud computing that combines some on-premise resources and infrastructure, a private cloud, if you will, and also perhaps a front end or even back end in the public cloud environment. And the idea is to sort of leverage the best of both worlds. But in practice, it turns out that the attack surface of hybrid and private cloud is probably one of the more dangerous areas in terms of what could eventually lead to a major compromise of your organization. And we would be remiss in not suggesting also that there is a considerable amount of risk from not knowing what you're doing. And that at the most basic level within an organization that's exploring a multi-cloud environment or moving workloads between an on-premise infrastructure to the cloud, et cetera, as a result of scaling to meet application demand, that connectivity and redundancy at the network layer is the vital ground. Because if you don't have redundant circuits, if you don't have a way of reconnecting, if your primary connection between your public cloud and your private infrastructure fails, your entire application is now pretty much useless. So when we talk about the hybrid threat model, we really have to come into the idea that it is adopted because of certain compliance demands, but also the result is we have a major investment that many companies have made in their on-premise TIN, or in perhaps even a private data center that they have established their own infrastructure in. But then they need the massive compute power of Azure or certain services from Azure or Amazon or Google in order to scale to meet the demand. And what they don't want to do is make an investment in millions of dollars in on-premise capability when it's maybe very transactional and it only is there to meet demand. There are also certain services that you can get, such as S3 buckets for storage of information, or even ELK stacks that you can bring into the equation that only kind of exist within the Amazon or Azure or Google ecosystem to properly scale when you're certainly confronted with massive analytics questions from data science. So one of the fundamentals that we kind of came up with was that at any scale, web app security is not a technology problem. It is a human communication problem, and security controls can only control, not stop the bleeding. And I have two experts with me that can attest to the bleeding that organizations can face. And I think what we'd like to do is first introduce Sean to really kind of discuss the difficulty with the word architecture and what kind of challenges that has in an enterprise environment. So, Sean, do you want to maybe comment a little bit on this slide? Because after all, this was one of the slides that resulted in quite a big debate. Sean, are you there? Sean?
Is his mic muted? Is he muted?
I'm not sure. Mike, do you want to maybe jump in on Sean's behalf while he sorts out his communication?
Yeah, absolutely. And first and foremost, full disclosure, I'm not an architect. I'm an information security manager, so I head the service in the company I work for. But I think architecture has become a little bit of a grey area in organizations. So what is an architect? What is their primary purpose in the organization? And in a lot of companies, you tend to find that architects are kind of super developers. They've come in and worked their way up through the ranks into a relatively senior position, but not necessarily understanding what architecture actually means. And I think that is a problem. And they're a little too close to perhaps the software development lifecycle itself, whereas actually they really need to probably become a little bit more abstracted. But this is only through personal experience, so I can't speak for other organisations. But it's about having that holistic view of what the strategic aims are of the applications and the services that you're standing up. What value are you trying to return to the business by selecting one cloud provider over another, AWS versus Azure, and all that kind of thing. But it's the architect really that understands the bigger picture. They understand the wiring under the board, but not necessarily to the level of detail that a developer would, but they understand the other side of the board, which is where all the components fit together and how they should correctly fit together, and all of the inputs and ultimately the outputs of what that objective is and what that system is aiming to deliver. So that's my kind of bird's eye view, I think, of architecture, and certainly in the context of security. And you can have security architects in businesses, and these roles do exist. You see them emails from LinkedIn offering you a security architecture role. But really, as Amazon would say, or AWS would say, security is job zero. And I believe we've got, I think, John, you're at Amazon, so that's cool. So that term probably isn't alien to you. And what they mean by that is that security is everyone's responsibility. So whether you are in the context of delivering technology solutions, it's everyone's responsibility to consider security implications of the thing that you are about to build, or the thing you're about to modify, or the thing you're about to buy, which is equally as important. So yeah, I think that's my take. I've filled for Sean there. Hopefully he's back on with us.
All right. Hey, Sean, give us a check 1, 2. Can you give us a check 1, 2?
You can't give us a check 1, never mind a 1, 2.
All right. Well, we'll get Mike to weigh in a little bit later while we sort out the comms issues with Sean. But I want to say that one of the things that I think became really interesting to me was in the discussion, Sean was very adamant about the importance of a software security architect or the software architect in the organization. Because what we found is it's amazingly expensive. It's amazingly expensive to add security after the design phase of your application or your service that you're going to stand up. And without that institutional knowledge on secure coding, there actually can be limitations and or security vulnerabilities built in to the application that you're not going to find until, it could be too late. So I think it's really important to tease that out. Now, obviously, we're talking about infrastructure. We're talking about major providers of infrastructure, Azure, Amazon, and, of course, Google as well. Google being a big fan of Kubernetes service, which is basically standing up containers that are in themselves microservices. Now, interestingly enough, managing workloads across Azure, Amazon, and things like Google can be a huge challenge. And this is where VMware's cloud services come into play that can manage all of these workloads. And I think when we talk about modern applications at the highest end of enterprise architecture, you have to have options. You have to have abilities to load balance and or move from provider to provider as required. So I want to talk a little bit about, the data center that you own and the fact that it might be very swoopy, it might have incredible capabilities, and then there's this iconic slide from a United States data center that is just a complete jumble of older equipment. You have to understand that at scale, when you're talking about moving between infrastructure that is cloud hosted or in your private cloud, there has to be challenges when it comes to performance. And one of the key tests is actually part of a QA process of where you load these systems so that they perform as expected and scale automatically. And I know that in the VMware ecosystem, as well as Kubernetes, there is the ability to rapidly scale to meet demand. And obviously, we've seen that in massive organizations such as Netflix that have literally terabytes and terabytes of data, and they're able to move that data from different geographic regions depending on the demands of their viewers. So massive scale requires capabilities that are really beyond. And when you're in that business, where each transaction uptime and response time is something that is measured down to the milliseconds or deciseconds, and that becomes real value for your organization, you cannot afford to make mistakes. So two sort of lessons learned so far in our view of where we're sitting in terms of multi-cloud, and is that there is a tendency to ask for more of everything. And this is an unfortunate thing with architecture not being present, because one of the problems that we see is that the solution may be to throw more storage, more CPU, and more memory at an application. Now, this might be an easy fix for some poorly constructed code to get you through. But then what happens is it potentially massively collapses when at scale. And a lot of times the performance bugs are not manifest unless you are at the top end of performance and you're seeing that curve come back. So in a way, we have two problems, one echoed, of course, by Bruce Schneier, which is the worst enemy of security is complexity. And then I talk a little bit about the data inside the organization that is closed off and unavailable but needs to be, versus data that is public and is now accessible, are both significant problems to the organization. And I think when we're talking about multi-cloud, we're talking about scale, in which case problems can manifest very quickly and your organization's operational capabilities can be impacted. This is especially case in high volume transactions, such as your Amazon storefronts of the world, or airline flight bookings and things like that. Now, the number one takeaway from this presentation that I really want to sort of illustrate and underline is really about do not start disabling security to make it work. There are all sorts of horror stories from gray hat warfare about folks that have inadvertently, oh my goodness, somebody's screaming. Goodness. Can we get you to go on mute if you're not talking? Thank you. Fantastic. Goodness. All right. Thank you. So I think one of the things that we see quite often is an effort by organizations to quickly put things into production. But unfortunately, many of the security due diligence requirements are potentially not implemented, and therefore what happens is publicly exposed records. Do we have Sean back on the line?
Hi, I'm sorry about that. My phone was giving me problems. Should be back now.
No worries. I wanted to bring you in on this particular area because you have discovered on a couple of occasions treasure troves of data that is usually the result of a front-end to back-end problem where security's been disabled. Do you want to talk maybe a little bit about some of what you've encountered?
Sure. So the one thing that you have to realize is often development teams are under pressure to get functionality out and deliver. And this is why sometimes security teams are seen as a roadblock or a hindrance. Some of the security controls can either hinder it completely or significantly increase the amount of complexity and effort to do that. So that it's no surprise that they actually go and disable some of these, because guess what? If they disable it, it suddenly works. and hey, to them, the job done. And I think one of the bigger problems around that is, to them, everything seems fine, but they don't actually understand the implications and the results of doing that. What does it mean for the organization and that data from a security point of view? What happens when it gets leaked? Or it may not necessarily be leaked. Too often we see even groups out there looking for open databases and that kind of stuff. And you suddenly find yourself in the media for the wrong reasons. You may not even have suffered a attack or a breach itself, but you still end up in the media. And that's obviously impactful for reputation and that. So I think the biggest thing is making developers and those responsible for configuring these understand the risks and what's at play and what's at stake, really.
I'm familiar with a lot of the Amazon controls, and they do start warning you as you disable and make things public. That's good, but I do know that in other implementations on other platforms, it's somewhat difficult sometimes to completely understand the level of exposure of the data. And because security controls across, your private environment you might know quite well because you've built it completely, but then, within the Google, the Microsoft, and the Amazon, if you're not super comfortable in understanding all of the different types of controls available in terms of access control lists or authorization or setting up encryption properly, you can inevitably and unfortunately expose data. Great point, Sean. I truly appreciate you wading in there. So we've come up with the top 6 kind of threats in the multi-cloud and hybrid cloud environment. And interestingly enough, we're not really going to get into the evil, malicious actors here. We're going to talk about what we see this from the application layer mostly, because not only am I blessed with 2 mates that work in that space and have worked in that space for a very long time, but I think it's really important to understand that the types of organizations that are going to be using a hybrid cloud or multi-cloud environments are looking at it from the perspective of running applications on those platforms with either the front end, the back end, or certain analytical functions pushed off into the cloud. And I think it's fair to say that this area is one that is that the knowledge basis of what we have is still a complete challenge. And we can see that even the best of the best providers out there, your Microsoft, your Amazon, your Google, they do have failure. They do have interruptions of service. They do have downtime. And that can cost the organization a tremendous amount of money if they haven't architected to sort of do some things like self-healing or to be able to scale internally and have the capacity or shift to another geographic region that's not impacted by an outage. So, when we talk about the understanding is really about thinking about our orders of magnitude challenges. And, some of the things that identify, difficulty within the organization of understanding both scale and performance and that hybrid cloud relationship are when the production environment is not a mirror image or as close as you can get to the development environment. And I literally heard these 3 things come out about, what do you mean it doesn't work in production? It worked fine on my machine, right? This is like old school development where there isn't an actual development environment. What is a software development lifecycle? And great code, is it secure? Did you test it? If these are questions being asked in your organization, it's highly doubtful that your foray into multi-cloud or into hybrid cloud is going to be successful. Mike, do you have any thoughts on, knowing when you're ready to go a hybrid or multi-cloud environment? Because you do a lot of hosting for a lot of organizations at Zen. Go ahead.
Yeah. So just keep it on that slide that you've got up, really. So yes, we do have a hybrid. Well, we have a hybrid in many ways because we have different cloud providers that we utilize. But we also have quite a significant on-prem physical footprint that's not going to move anytime soon for, well, various reasons, technological reasons, cost-benefit reasons, etc. And so it is quite a challenge. Now, just to pick your first quote there about what do you mean it doesn't work in production, it worked fine on my machine. That's an issue around continuous integration and continuous deployment, okay? So what we'd like to think nowadays is that many organizations are adopting these practices, both in terms of process and technology and people. And they are feeding their software from development through testing, and hopefully much testing, or much of the testing is done in an automated fashion. Certainly from a quality point of view. And when we say quality, we include security as an attribute of quality, and that's an important takeaway I'd like to share. That often we talk about, did it pass unit testing? Did it pass smoke testing, integration testing? Well, did it pass security testing? And that's because security is a front seat passenger in the quality of the software or the application that you're developing. So that's a really important point I'd like to make. But if you're getting CI and CD right, then there isn't any major conceivable reason why the fact that it worked on your development environment or in your development environment shouldn't mean it doesn't work in production, because the checks and gates and balances are all applied, and the software reflects the software that it was when you were sitting there crafting it in the first place. So that is the modern SDLC. It's more automated. It's not about necessarily the BA going and gathering the requirements and then having endless design meetings and all that kind of thing. It should be much more smooth than that, and there should be far less margin for error, because the technology and the processes that you're applying are doing the checks and balances around the quality of your software. So that's important. Another important point is around the security testing itself. So yes, there is automation, lots of it. There are many providers of a fairly good static application security testing and of course dynamic application security testing that are out there, and they do carry a lot of the workload. They do hell of a lot of the heavy lifting to find the common problems, the OWASP top 10 level things that you tend to find are prevalent in code. But they don't do all the work, and that's the point. There is still a level of human interaction and human intelligence required to look at a problem and provide that kind of real-world, pragmatic view. Well, actually, yes, this is a problem we need to fix, or alternatively, this doesn't present a risk to us, then the software is fine in the condition that it's in. But the point being is you don't rely 100% on the automated approach to security testing. There has still got to be a little bit of human intelligence applied. And I think Sean has a view on how you can make it easier to securely code if you follow some basics right. Is that right, Sean?
Yeah.
Again.
He's here. Just come very quickly, because I don't want to take too much time. Basically, as I put out a tweet today, the simplistic way is just use a modern framework. A modern framework is covering a lot of the common vulnerabilities that we've seen over the years that haven't gone away, and they're going away now with the modern frameworks. And then, as Mike said, like the integration of the testing within your build cycle and having almost gates, especially for high-risk vulnerabilities, and having some sort of stop gate for that, so that the issues are fixed before they even end up in production. And then also looking to leverage services and libraries and that kind of thing that handle some of the more complex security-based things, so things like authentication, especially things like single sign-on, that let them handle that. Let them handle the complexities of things like encryption, so you can actually focus on delivering an application and the business functional requirements. So yeah, that's it in a high-level, quick overview.
I think I'd just like to add, sorry. Sorry. We don't want to steal your thunder and all that stuff. It is your talk at the end of the day. But we're talking, strictly speaking, about application security in the kind of sense that we're writing software, and that's fine, and everything's valid. However, when you're in the cloud environment, of course, everything's an application, right? Unless it's physical, it's more or less an application.
So when you're in the cloud environment and, choose your poison, is it Azure, AWS, Google Cloud, whatever, there are security considerations around the configuration of the use of that platform. So you talked about S3 buckets earlier. I think in the early infancy of S3 buckets, they were kind of open to all by default, and not the greatest approach. Amazon has completely changed the paradigm of how it secures its platform now. Everything's closed by default, and you have to configure it to make it talk to the other thing it needs to speak to. And that's really cool. So you've got that, and that's fundamentally important. And this is not software developers in the traditional sense. This is administrators of the platform that may well be hosting software applications, bespoke systems, but you've got to get the underpinning infrastructure right too. And so, for example, in Azure, you've got MCAS, Microsoft Cloud Application Security. It's a whole vast country of things that you need to be doing or considering at least. And similarly with AWS, you've got the concepts of security groups, you've got concepts of virtual networks, you've got tooling, endless tooling in both platforms, things like Trusted Advisor, Macy, GuardDuty, etc. They're all there and need to be factored in to the life cycle of that application because it's going to live in the cloud. Then you need to be securing the underpinning infrastructure. So that was the point I wanted to make there.
Yeah, it's great. And I think, this is a great little checklist that we kind of talked about in terms of the 3 things to look at. I want to go and dig into this just a bit because one of the fundamental things is that if you are in this hybrid environment where you have, say, the front end to handle a massive surge in transactions, and then you are back-ending that into your own database servers, or you have a vice versa configuration, whichever. It really doesn't matter. The problem is a compromise on your cloud platform could end up attacking and corrupting and or exfiltrating your database, and vice versa. You can cause a lot of damage to an organization by finding a way into their on-premise environment and then getting up to the cloud. So from a security perspective, the security of the application is important, but also that connectivity and those connections become very important as well for the security considerations. So one of the things that we identified in our discussions that we're having, we'll talk a little bit about the genesis of those discussions in the Q&A part, but was really the challenge of the asset environment and understanding, the issues around egress and ingress and the highly complex hybrid environments, everything from the use of DNS and load balancers, etc. Because when you're talking about scale, it's not just one cluster to another cluster. There are a lot of moving pieces that need to all be properly aligned and functional. And one of the issues really we have with modern application design is web pages today are essentially a bunch of APIs that create the web page on a fly. And Sean, do you want to just make a mention about how critical the security of the different APIs that are now really part of creating that user interaction and that page on the website, and the danger of, the existence of the fact that maybe some of those APIs are cloud hosted and others are on-premise and back-end into databases that shouldn't be publicly exposed?
Yeah, so as you mentioned, there's a service-based API, so SaaS-based, and those, while great, you can offload some responsibility to someone else. There are other risks, such as I don't always enjoy using this term because it's getting done to death now, but supply chain vulnerabilities. So what happens if that organization becomes compromised? How does it affect your application and your service? And then certainly, if you're looking towards your internal APIs, again, that's software that you need to maintain and software you need to fix. So making sure those are appropriately patched, monitored, security tested, security reviewed, and all of that is also really important. To your point about like the public cloud databases and that, making sure that you have the right configuration if you're using a service, such as like the cloud-based solution. And yeah, do following best practices around security on them and making sure that you're testing them and actively monitoring for for instance, someone disables a security configuration, making sure that flags up in some alert somewhere.
We'll get into some of the.
Sorry.
Yep, go ahead.
Ian, sorry to cut in there. I just want to pick up on a point Sean made about things that appear to be done to death. So supply chain being the example that Sean cited there. But I don't think they're being done to death, actually. I think the reason that we're still talking about them is because people are still not getting them right. And they have still strong validity in debate because we're still not getting asset management right. We're still not dealing effectively. We're better at it, but we're not dealing with it fully with encryption. We're still not getting access control right. And these are the very basic things that lead to a compromise in the first place. So I think we'll keep talking about them until people start doing them properly.
Absolutely, and I think this really underscores the 2 points that I have on that particular slide. It's really around the architectural review needs to catch it early in the development cycle. Otherwise, you could literally lose many cycles of having to try and rework it. But one of the challenges without a solid architectural foundation, especially on the software side, is making sure that dev is aligned to the use cases and the business case justification for the effort. And all too often, if the direction and specifications of the application that you're trying to develop aren't really crystal clear, it's going to drift off what the intended exercise was. And I've seen this time and time again. I mean, when we look at a modern login page, there is the request for the user ID first, and then on a second page, if the user ID is valid for the application, then you get to add the password on a second page. So there's all of these different techniques that are being adopted to try and prevent, compromise at scale in an organization. It's really important to understand that when the company comes to you and says, well, it's a hassle to have two screens, one for the login ID and one for the password, you need to be able to articulate and explain the types of threats, the types of attacks that architecture thwarts. So this is sort of a really interesting slide that another beer farmer who couldn't join us today helped us sort of have a great discussion around, is really a iterative process of going through, of understanding what the threats are to the organization. So based on the particular functionality of that code and what you're asking them to create. So of course, threat modeling again, and then having the secure coding practices in-house, looking at specific training for your developers, specific training for DevSecOps in terms of working in collaboration with dev, continuous training, right? Not just sort of one-off course, once a year. And then, Mike made the huge point about making sure that SAST and DAST are part of the automated build process in order to catch anything I think we could call crazy from getting into the actual build. And then, of course, interestingly enough, we see an increased responsibility and role for QA. And I think this is where, the vital ground happens in a lot of organizations, is making sure that the security discussion, yes, it's automated, yes, it's built, but it's also extended to the QA process in order to make sure you have security through the whole cycle of building. And of course, then, your tests will come back with vulnerabilities that need to be managed at different levels. And then, of course, the process is a rinse and repeat process. Sean, do you see this sort of as the future of where businesses are taking enterprise application development in those kind of environments where they're higher risk, they're on-premise, and they're also in the cloud?
Yeah. Certainly what's on the screen is things that businesses should be following today. And at the end of the day, I don't view cloud applications in the cloud. They're essentially the same, whether it's in the cloud, public cloud, private cloud, on-premise. You essentially, if doing things to the best standards and best practices, you'd face the same risks. The only difference with public cloud is you now having the risk slightly increased, where you having on someone else's infrastructure that you have no control and sometimes a lot less visibility over. But if you still configure things, so things like firewalls and appropriate network segmentation map, it's really no different from the cloud to on-prem. You still have to focus on the same things from an application security point of view.
Yeah, and I think that's a great point, because even though the code might be, the application can run on, in-house or on the cloud, really the art is understanding, because, you might have built your data center over 5 years, 3 years, or even 10 years in some cases. But the cloud controls are all kind of new and sparkly. And if you're not, as comfortable working with those security controls in the cloud, then your application might be inadvertently exposed to a different threat landscape than you would have faced on-premise, Let's talk a little bit about encryption, because I think this is another real interesting area. When we say the words encryption, I think, everyone now understands that HTTPS of some sort, and hopefully with a robust cipher suite, is really the way to go. But often or not, the configurations that I've seen is much for wanting. And there's a real sort of, I think, challenge in encryption right now that we have, because it seems like the more in transit we rely on encryption for protection, the less visibility we have over our organization. So you start seeing things like proxies being put on the edges of networks to pick apart the SSL or TLS connections in order to try and understand the application behavior and what's going on. This is a huge challenge, and again, if your development team hasn't been doing this and has been relying on DevOps, for instance, to terminate encryption at the load balancers, where everything after the load balancer is clear text, there's a huge potential attack surface right there, especially when we've seen CVEs come out that allow a malicious actor to get on the other side of your load balancer or on the inside of your load balancer, and that's potentially where you see situations evolve where massive amounts of account data and PCI data is sometimes scooped up. Any thoughts, Mike, on the challenges of encryption? Did I get it right, or is it gotten a lot better?
You got it right, I think. One of the bigger challenges for organizations is managing their own public key infrastructure, PKI, because you can't necessarily auto-generate certs, and things just out in the middle of the night stop working, and customers get upset, and members of staff get upset because they can't do their jobs properly. So I think it is a problem. There are other mitigating controls that you can put in place to perhaps tunnel data from your cloud into your on-prem infrastructure and systems. Or you could just manage your own PKI and bite the bullet and do it properly. So I think you'll find quite a lot of organizations do this. They'll terminate their TLS, as you described, on the load balancing infrastructure and clear text it back to the back office systems. It does happen. But it's fixable. And I guess ultimately you've got to understand your threat profile, in terms of the likelihood. If you've got effective firewalling on your on-prem or on the link between the 2 points, then you might accept that and think, well, that's actually adequate. We're happy with that level of security.
Awesome points, as always. Thanks, Mike. So the last sort of threat to the organization is the compliance word. And it's not so much of a threat as a challenge, because in order to figure out what's going on, and in some cases, especially if it's customer transactions or financial transactions, there's a data retention piece that's required. There's a potential, data science opportunity for understanding the massive amount of customer transaction that you have. So you're shipping hopefully anonymized data, but possibly not data, off to a data lake and running analytical functions against it. But we're living in an age now where finding out what an application is doing and whether it's misbehaving, if you will, or has been successfully compromised or attacked is a job for a SIM. And the huge challenge from hybrid and multi-cloud environments is having one single source of truth when it comes to the logging and the SIM interrogation, if you will, of the behavior that's going on. Because the amount of moving parts at scale can be a tremendous amount of systems. You know, you're talking about applications that could be hundreds, if not thousands of servers spread over a wide geographic area. So being able to understand what is going on at a massive scale is a huge challenge where, you know, organizations sometimes turn to ELK stacks and other techniques. So I want to point out fundamentally that logging itself is a challenge that needs to be talked about because logging everything at scale is not an option. We have to really figure out what is the important information we know, what are the choke points and the threat actors against the threat models that you have. How are we going to detect that something has come off the rails? And keep in mind that the logging of actual transactions in order to meet compliance requirements is completely different than having a platform that gives you insight into application behavior. And I've seen organizations that do not separate the two, and so their SIM becomes ineffective because it is simply overwhelmed by the amount of data. And the Splunk implementation that they have done now becomes a multi-million-dollar affair because, of course, Splunk costs can skyrocket with the amount of data that you're trying to consume. So as we move toward, go ahead. Somebody has a point?
I was just going to say, this goes right back to the beginning of the conversation around architecture, and asset management. So another key takeaway, it all begins with asset management, right? Nothing can proceed without good and effective asset management. If you don't know where it is, what it is, that it's there at all, you can't assure it, you can't protect it. And it starts with that. The second point around architecture is that you expect that your networks and your infrastructure routing, for example, are architected in a fashion that you minimize the amount of logging that is actually happening. So if you've got complex firewalling in place where firewall A talks to firewall pair A talks to pair B, and then ultimately the traffic goes out to the internet or comes in from the internet, then you're going to get multiples of the same traffic. And that is a problem. It's a huge problem, and it's a costly problem too in terms of analysis time. But also, if your SIM provider is billing you around events per second, then you're paying far more over the odds than you actually probably need to do. So that's where architecture comes to the fore, to create clean architectures and designs and deployments. And then your logging is actually richer, much richer, and contains less noise.
Yeah, and I think that's a critical, absolutely critical point. Is that, you know, check and see if you're literally got this massive duplication effort going on in your edge, in the edge of your network, and in fact in your database clusters as well. So I want to talk a little bit about the path forward because this was probably one of the more interesting discussions that we had. That Sean lives and breathes this stuff at Immersive Labs. I mean, his life's work is to try and get secure software development lifecycle into the DNA of organizations. But frequently, Sean runs up against security people, and I'm sure they're lovely people, and I'm sure their heart's in the right place, but they seem to think that if it passes a web vulnerability scan, then all is well. Sean, maybe break down that myth a little bit about how just because, you know, you zapped it or you NetSparkered it or you're Outposted 24 it doesn't necessarily mean it's fit for purpose and secure.
Yeah, sure. So those scanning tools are very good at finding specific types of vulnerabilities. So you're talking about like kind of static type vulnerabilities in a sense. So ones that are not really complex in nature, So your things like your cross-site scripting, your SQL injection, even things like misconfiguration to extent. Where it's not going to pick up is on things like your access control. So should this user have the ability to access this piece of the platform? It's not going to know that information. That's where you're going to rely on humans and pen testing. Other things, including like business logic. So if you have a password reset feature, can someone else request a reset password on behalf of someone else and gain access to their account? Those are things that, like, those tools aren't going to be able to assess and test. And this is why you need things like secure design when you're coming up with these features, but also those periodic pen tests, those manual tests. Those manual tests will never be replaced. You still need a human to do things. And the other thing that also is worth considering is sometimes smaller vulnerabilities on their own don't see high risk, and you may accept them. But when you start chaining vulnerabilities together, which is often what happens in a security incident, it's not just a vulnerability, it's a sequence of failings and vulnerabilities put together that ended up in the incident. So it's tying all that. And again, a tool and that's not going to really help with that. You need humans to put those things together.
100% agree. So we're on the last slide of our presentation, and we'll quickly transition over to a brief Q&A. But I think, I look at this now as if you have the secure coding background, that your application has been tested, you have security as the DNA of what you're creating, you have engagement from architecture and clear understanding of what you're delivering, there's still a heck of a lot of tech, tactics, training, and procedures that your organization is going to have to adopt. A content delivery network and web application firewall and scenes and load balancers and multi-factor access controls for the environments and the repos and signing key management. I mean, we sat down and we had quite a large discussion on all of these different controls and why it's so important that this is, at the end of the day, when you're talking about multi-cloud and hybrid cloud, this is a team effort, and everybody needs to be rowing in the same direction. So with that, John, I think we'll flip over and we'll do maybe a brief Q&A if there are any questions.
Thanks, Ian. Thank you very much. Thanks, gentlemen. That was awesome. So let's get to, we've just got a few minutes for a couple of questions. We've got one here from Russ. He's asking, what if you don't need the enterprise level that is, that's from Edgar. What if you don't need the enterprise level that is VMware? Is Hyper-V compatible?
So your hypervisor, again, is just dependent really on what services and what loads you're going to be running. So, I mean, we talked about Kubernetes, we talked about VMware, we talked about Microsoft's hypervisor infrastructure. At the end of the day, pick what you need in order to manage the workloads that you're going to be expected. But keep in mind that if you're going to talk about scale, you need something that is going to be able to handle at-scale deployments. And the ability to massively replicate, your entire front end to a different geo is going to be a big-ticket piece of software. And some management systems may not be up to that task. Again, this is where you want to do your research. You want to be very specific in terms of what your scale is going to look like. A lot of organizations are very comfortable just using, the Amazon stack for all of their needs. And hybrid cloud really only comes into effect when you're talking about a need to deploy massive scalability in a short period of time, but don't want to make the actual investment in all of that hardware that you would need to meet peak demand.
Thank you, Ian. Guys, we have just run out of time. We got a bunch of questions here come in right at the end. Be okay if we get those to you via email so that you can send some answers?
100%. Absolutely. I just want to say one quick thing. So Ian touched on the genesis of this talk at the beginning. and the material that's been produced. So we as a group of people produced this material while we were all sat in our houses, and Ian was at 35,000 feet just clipping the southern tip of Greenland on his flight from London to Toronto. So it's two things. One, excellent collaboration between the group of us, and two, living proof that technology isn't actually all that evil. It works.
Yeah, that's right. And thank you so much, guys, for your support on this, because as you know very well, I am not an application security guru, but I have some great friends that are.
Well, thank you, Ian. What a great session. Many thanks to our presenters here. Let's see, we're going to take a short break right now, but we'll be back at the top of the hour for our second session, Security Best Practices for Hybrid Multi-Cloud Environments, led by John O'Neill, Chief Technologist at AWS Solutions, and led by my colleague, David Rammel, who heads up the editorial team at Virtualization and Cloud Review. Many thanks to Ian Thornton-Trump for a great session, and to his wingmen, Mike Thompson and Sean Wright, for joining in. And thanks to VMware for making this entire summit possible. Now would be a great time to check those extra resources on your console provided by our sponsor. Remember, we're giving away a Surface Pro 7 to one lucky attendee at the end of the third session. You must be present to win, so stay tuned. Back in a few.
Okay, welcome back, everyone. Thank you for being here, and thank you to our speakers, and of course our sponsor, VMware, for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the second session of our summit called Security Best Practices for Hybrid/Multi-Cloud Environments. Our speaker for this session is John O'Neill, Chief Technologist at AWS Solutions. John's professional IT career began as a teenager, taking him on many wonderful adventures over the past 30 years. John's IT path started with programming, but branched out quickly. Opportunities from the help desk to the corner office shape his IT journey. Specializing in security, system, and infrastructure technologies, John's broad skill set includes desktop and server OS, identity management, networking services, network architecture, IP telephony, and cybersecurity. John, it's great to have you here. Please take it away.
Thanks a lot, David. It's great to be here. I always love the opportunity to participate in these great discussions with other experts and most importantly with our audience members. So I'm looking forward to seeing their questions and comments as we go through this, and hopefully providing a lot of great insight. We're going to go ahead and jump in, and I'm going to start kind of with some of my high-level thoughts when I look at hybrid and multi-cloud security, and I discuss it with executive leaderships, board of directors, those kind of things. The way that I bring it to them is, of course, using a sports analogy, and what I tell them is that we have to pitch a shutout, right? It has to be a game where the opponent scores 0 points against us, because even 1 point means we've lost. And there's a number of reasons for this. One key point is that cybersecurity breaches are no longer a matter of inconvenience. They're no longer a matter of, well, somebody can't do their job for a little while or whatever. They are absolutely destructive. And they destroy not only data and IT systems, but they destroy customer relationships, they destroy customer confidence, they destroy organizational credibility, and, you know, in many cases, they can even destroy relationships between individuals. I've seen cases where relationships were irrevocably harmed between, you know, employees within an organization and outside providers, all sorts of things. It's just such an overwhelmingly, overbearingly stressful situation when you have a breach that there's some things that just don't come back afterwards. And another thing that I like to bring up is that, for some organizations, a breach doesn't just shut down IT systems. It can actually pose a significant physical danger to the organization. So think of a manufacturing company, for one example, that uses a lot of computer interfaced machinery. And what happens if during that breach, a piece of machinery moves in a way that's unexpected? So an employee could be in the way of that, 2-ton press that just decides to close, or, a crane that decides to move. And, bad things can happen. Now, luckily, we haven't heard a lot about that, but our job in IT is to prevent things, not just wait for them to happen and then prevent future occurrences. So that's one that we really want to watch out for. And at the end of the day, I don't know organizations anymore that can take a cybersecurity breach and just write it off as cost of doing business. Organizations can no longer afford a breach. End of story. Okay, and so with that, let's jump right into kind of some of the topics that we're going to look at when it comes to evolving your security strategy, your security vision, and your security tactics to address your multi-cloud, hybrid cloud environment. The first thing I'm going to talk about are a number of organizations that have resources to help you. And the top of my list is NIST, okay? And NIST, the National Institute for Standards, is a U.S. agency, but they have developed a framework for cybersecurity that you see here kind of outlined in their infographic. But it really is a strong framework to build your plan around. And one thing I'm going to say about NIST is that their standards, their recommendations, their guidance is considered so strong that most cybersecurity insurance firms perform audits that look at a lot of NIST compliance factors. Let's talk about some of the key NIST documents that you can go to and you can kind of look to for guidance. There's 800-53, and this covers security and privacy controls for IT systems and the organizations that use them. This is one that is audited against frequently. You'll find a lot of checklists if you just fire up your favorite search engine and you search on NIST cybersecurity audit checklists. You'll find that a lot of them are based on this. But then you also have some newer documents, and most of the cybersecurity stuff falls in the 800 range in their document numbering system. So this one is 800-171, and this covers protecting basically what they call controlled unclassified information, or CUI, in non-federal systems and organizations. This one comes into play if you service a customer or you work with a vendor who is providing paid services to the United States federal government. They will often require you be audited against the guidance in here. So you may not even be directly dealing with the U.S. government, but one of your customers or vendors is, you still will end up following under some of the things in here. And then the final one that I'm going to talk about, because this is really going to come up throughout our discussion today, is the NIST 800-207 document, which covers zero trust architecture. And I'm going to get more into zero trust in a little bit, so I won't go too far into that. But those are 3 documents that if you haven't taken a look at them, please take the time to go and look, because if you haven't been asked to respond to how your organization is complying with those documents, I would say it's a matter of time, because if you have cybersecurity insurance, if you deal with partners who may have cybersecurity insurance requirements, or, like I said, federal government interactions, you're going to need to deal with those things. So when it comes to cybersecurity and looking at your solution and how you're using it to mitigate risk, you really need to make sure that you're aligning with the organization as a whole. You're not sitting in an IT vacuum deciding on what's aligned and what isn't, what is appropriate risk and what isn't, because I can assure you that all my experience, all my information tells me you'll miss something, okay? And the only way to avoid missing something, or to avoid getting it wrong, is to get out of that bubble, engage leadership, engage users, engage business units throughout your organization, and find out what is their risk appetite, right? What things are they willing to accept the risk for, and what things are they not? Because that risk appetite gauge is how you're going to decide on the priority of the risk mitigation things that you put in place. If you find that your company really isn't worried about losing email, for instance, for a day or a week or whatever, email just isn't a thing. Now, I can't imagine a company that's true for, but let's just play along in the scenario. But you find that, hey, keeping those trucks moving that are distributing your product to your customer base, that is absolutely critical. Then you would need to focus on things that protect the network systems that are out there in that warehouse, out there in that distribution center, before you worried about the things that protect your email systems. And it doesn't mean you're not implementing things in both areas. It means that you have limited resources, being time, being people, being money, and you need to spend them first on the things that are most important, and then work down the list. And there is a NIST document. It's currently in draft status, but it is a great document that helps provide some guidance based on research to help you. And that's listed there. It's 8286B, which is prioritizing cybersecurity risk for enterprise risk management. And NIST does love to give long titles to their documents, so be prepared for that. Now, moving on from NIST, let's talk about another U.S. government agency that actually ties hand in hand with NIST, and that is the Cybersecurity and Infrastructure Security Agency, commonly referred to as CISA. And they are, in a nutshell, the cyber risk advisor for the United States. So when the country as a whole needs to be aware of developments that are could affect everyone from the smallest mom and pop shop to the largest nonprofit educational agency or group, CISA gets involved and plays a lot into it. And they provide a lot of guidance and a lot of structure around helping all organizations increase their cybersecurity defense stance. So making all of us better protected with lower risk. The final agency that I want to talk about, or organization I want to talk about, is the Center for Internet Security. Now, this one is not a government agency. It's a non-for-profit. It was founded quite some time ago, right? And so right around Y2K, and the things that it tended to address back then were very different than what they tend to address now, 21 years later. But they still focus on a core mission of providing best practices for cybersecurity, for information technology security. So you can go and you can get from them baseline configurations and best practices that you can just change on your systems, whether they be database systems or identity management systems, different applications, OSs, whatever, firewalls, network switches. You can find a lot of great best practice baseline information there at the Center for Internet Security. Now, some of it is available for free to everyone. Some of it you need to be a member for. But it is a great organization to get things from. Now, of these three organizations, as I mentioned earlier, cybersecurity insurance providers will often base their audits around things that come from these organizations, but also the software you go and buy or that you get provided to you from AWS or Azure. We're going to talk about some of their default easy config tools later on in this. Those things are based around applying a lot of these settings, recommendations, and baselines automatically for you, if you will. So now let's get more into the tactical and talk about the actual tactics that you can take, the actions you can take immediately to increase your hybrid cloud, multi-cloud strategy and safety. So first off, take the approach of starting secure. Don't start with the easiest to deploy configuration simply because it's easy or quick or cheap, any of those three things, because what you will often do is negate all of that benefit by the effort and resources you have to spend on the journey to get from that point to being secure. And in the time that passes while you're going from easy but insecure to secure, you are at high risk of a breach. And like we talked about right at the beginning, you can just not afford a breach. Your organization can just not afford a breach these days. So start secure. Use things like Azure Blueprints and AWS Control Tower to deploy very quick configurations that implement those NIST standards, those CISA and CIS best practices and guidelines out of the box, right? And I put some links there because they show you how to do this quite easy. And it's great because you can implement dozens or hundreds of these best practice settings to your cloud environments with a handful of clicks, right? So instead of spending days, weeks, dialing in one by one all these different configurations, you can start out of the box with a secure configuration by taking advantage of Azure Blueprints and AWS Control Tower. So now, I titled this slide, "You Only Know What You Know," because a lot of us, as common sense as that seems, we just don't think about it over and over, right? We're not thinking about what are the limitations of the knowledge I have. And the limitations of the knowledge that I have are that cybersecurity is constantly evolving. It's evolving as we're having this discussion. And it's not just the threats are evolving, it's the countermeasures, it's the resources available. All those things are in a highly high state of flux. And so the first suggestion I have here is stay informed. Keep your ear to the ground, so to speak, right? And I think of those old movies where you see somebody lean against the ground, some old cowboy, and he puts his ear to the ground and says, "Oh, well, the enemy's coming, and they're coming from the north," or whatever, because he can hear the vibrations in the ground or whatever. Well, that's kind of how it comes to cybersecurity. Keep your ear to the ground, and the best way to do that right now seems to be social media, particularly Twitter. A lot of cybersecurity threats and remediations are being announced kind of in real time through Twitter. Now they're showing up in different areas, even on Facebook and not unconventional IT areas. But Twitter seems to be a really good one for keeping up with them. So follow those folks that are focused on cybersecurity day in and day out, and follow the organizations that are announcing things, and you will find that you get this constant kind of feed of that evolution, that movement. Second, keep yourself hyper agile. And what I mean by that is don't just be ready to intervene when something happens. Be in a constant state where you're actually already kind of moving. As I said, you're watching social media, you're doing all these things. So you're already in motion. And when something happens, it just shortens that reaction time even further. And you need to remain that way, both in your efforts to prevent breaches in the first place, but also in your remediation efforts. Okay, and a common, I guess, a common phrase used to describe your agility or your capability to be agile is the 1-10-1 marker. And what I mean by that is you should identify a breach within 1 minute. You should, within 10 minutes, understand what its total impact is and how it can and is affecting you. And within 1 hour, have ejected and eliminated the attacker. So it's a 1-10-1. Because if it takes you longer than 1 minute to identify the attack, typically it will be so far spread in your organization that your damage will be much larger than what you have the capability to deal with in a reasonable amount of time. And finally, keep up with reading. There's a number of books on security being regularly published and updated, or online blogs. Yuri Diogenesis, and I always mispronounce his last name, and I'm horribly sorry, or extremely sorry for that, but Yuri is a great guy, and he's created a bunch of Azure security fundamental books. So if you use Azure, he's a great resource to go and look for information to read on that. But there are numerous others out there. So I know it's not the topics we typically, or the content we typically want to read in our free time, but we're in IT, and we're in IT cybersecurity, so it's kind of our stake in trade, if you will. So now let's talk about our identities, right? Our accounts that are used to access our systems. Identity management is one of the things that I'm constantly out there talking about and helping companies with and different things. And when it comes to identity management, if it is breached, pretty much everything else falls, right? So it's kind of like if the gate of the castle is breached, the rest of the castle and what's inside of it it's just a matter of time before it falls. So you really need to make sure that you are living, breathing, acting in a least privilege and zero trust methodology. Okay? First off, zero trust. All of us need to understand that in a hybrid cloud or multi-cloud environment, there is no formal network perimeter anymore. So simply relying on firewalls, or even if you're using network security groups in the cloud or any of that stuff, that's all great and it's part of your strategy, but it isn't enough on its own, because your connections are mobile and you can't predict necessarily where they will come from and the environment that they will come from. So they may be connected to, Aunt Sally's home network, and Cousin Joe loves to download free BitTorrents and has malware running rampant. And all of a sudden, now with that connection into your network, there's a path. It may not be an easy path, but there's a path. So just zero trust. You don't know where the network perimeter is. It's constantly shifting. So you're going to start from a standpoint of everything has access to nothing. And then you add in exactly the access that's needed, when it's needed, for the duration it's needed. But it takes a specific action to do it. And yes, that inconveniences a lot of people, but convenience is the cost that we pay to increase security. And least privilege, this has been around for a long time, and we should all be doing it, but this goes into role-based access control and everything else. Make sure that your accounts are only empowered to do the functions that they need to do. For example, if you have accounts with domain admin rights that are logging on to any server that isn't a domain controller, then you're not using least privilege, you're not using RBAC. The only thing that a domain admin account should ever be used for is to log on to your domain controllers. Everything else can use a domain or non-domain admin account. It can be a local administrator account. It can be a different account to do those tasks, but you should definitely not be using domain admin accounts on anything but domain controllers. So it's really important that that you remember that and you get onto it. Okay. Also, you need to be proactive in documenting and monitoring all those identities, all those accounts, how they're being used, when they're being used. Okay. The common thing you think of is that, hey, I'm looking for accounts that are dormant for a long period of time, but still active in the system, so they could be breached and misused. But there's so much more to it. You want to develop trends and understand these are the things that users are logging into. These are the times when users are logging in. These are the networks that they log in from. Because the more information you have, the better you can manage the system. I've often said this throughout my career. You cannot manage what you cannot measure. So the more measurement data you have, the better off you can manage, the more you can dial it in. You can implement things like, hey, this user account has been active for a year and has never once logged in after 8 p.m. at night. Okay, well, I can put in restrictions that say it just won't be allowed to log in after 8 o'clock at night. That way, if it's ever breached and an attacker tries to use it at midnight, isn't going to work. And finally, on this point, it's not just those accounts that are used for interactive login. So it's not just my John O'Neill Sr. account or my Jane Smith account, whatever. It's also the accounts that are used for applications or APIs, application programming interfaces. Those things can be used for man-in-the-middle attacks, which then really can create a jump opportunity for malware, ransomware attackers to get beyond your systems. So now I'm going to talk about some specific products. And I live and breathe a lot in Azure in my hybrid cloud deployments. So I'm going to talk about some of their products here and things that can be used to help you defend. One of them is the Microsoft 365 Security Center. And this is where all the different security technologies you use in Azure and on-prem feed data into, so that you can have that timely data that I mentioned earlier and take proactive actions or remediation actions if you need to, right? And so you can see they do a number of things, like tell you how many of your devices, how many of your accounts, how many of your identities are non-compliant against the policies that you've had. Or, what is your overall security score based on patches deployed versus patches released, security of password policy, all those different things come into play. Now, what technologies are feeding into the Security Center? Well, it's all the things in what is now known as Microsoft 365 Defender. And this has had a number of names over the years, Defender ATP, all sorts of things. But now it falls under this Microsoft 365 Defender umbrella, and it's made up of these 4 core points. And you have Defender for Endpoint, okay, and that's what you push to all your Windows 10 devices and the computers on your network that ups the game for remote initiated virus scans, malware scans that provides the data back into the security center, that kind of thing. Of course, Defender for Office 365, where we're watching for malicious activity within the email and collaboration system, whether it be infected attachments, whether it be phishing attempts, those kind of things. Defender for Identity. Like I said, identity management is key to your success in fighting off these things. And Defender for Identity gives you all of your privileged identity management so that you can see if somebody all of a sudden gets an elevated role assigned into your tenant or into your cloud resources, that kind of thing. And you get all that data. And then finally, the cloud app security, the component that's providing security interfaces for your cloud-based applications and that sort of thing. These all make up that suite, and then they pass forward into the security center. So it really is a holistic approach, because that is the tenet upon which our security success is built, is that we will have multiple angles, multiple processes, multiple resources that we deploy to combat the evolving cybersecurity threat. We're not going to rely on a single product, a single technology, a single action. And so on that, now let's talk about your servers. And there is, so under that Defender suite that I talked about, okay, everybody thinks of kind of Gen 1 of Azure Defender. It was Microsoft Defender Advanced Threat Protection, or MDATP. And there's a SKU for servers and whatnot. But I know from working with the PMs and the product groups at Microsoft as a former MVP and such, that the money, the resources, the time that Microsoft is devoting towards server protection, threat protection, is all in Azure Defender. It's all focused on Azure Defender. And Azure Defender, as you can see in this screenshot, provides all this great information about your servers, how they're being used, what threats exist on them, what you need to do to mitigate those threats, and all that kind of thing. And I put a link there so you can see it. Azure Defender shows up in what is known as Azure Security Center. Okay, and that's, again, part of your holistic strategy for protecting your hybrid and multi-cloud environments. So rely on Azure Defender. Now, Azure Defender can be easily deployed through Azure Arc. There's a lot of Azure Arc integration. You can deploy it with PowerShell scripts and different things. It's easy to deploy. There is a bit of a licensing upcharge. I think it's in the range of $15 a server right now, but it is well worth it to get that advanced threat protection in place that is monitoring your servers. This is really key. And so now let's kind of move past that a little bit and talk about what I call one of the elephants in the room, and that is that COVID-19 has, amongst many other things, given threat actors a real slew of new ways to take their old tactics and techniques and programs and spin them to manipulate conditions created by the pandemic. So everything from phishing attempts, right? They go against people's fears or better natures, targeting the COVID pandemic, get people to expose credential information, that sort of thing. They also leverage things like malware, which is specifically looking for and targeting remote workforces, because so many workforces right now are still in some form or another working remote. We have huge organizations that went fully remote, but they haven't come back to fully on-prem either. So even if they've come back to partially on-prem now, a year and a half in, they still have this great sized workforce that is out there. And so these threats will target those workforces. And they target the VPN technology in use. So if you're still using the same mobile user VPN that you've been using for so long, let's say 5 years, 3 years, whatever, and you haven't gone in and looked, and it's using, authentication and encryption technologies such as triple DES or IPv1, those kind of things, you need to go in and adjust that. You need to make sure that your client VPN technologies are using all the modern standards and capabilities that are out there, because if you don't, the threat actors will leverage that and eventually find a way to breach it. Another big one that I see is that companies, to enable remote work, open ports and created openings for their workforce to get into their RDSH hosts and do things that way. And they leave those connections open and available. So what you want to do is implement technologies that protect those servers, particularly those types of servers, because once they're breached, they can create real opportunities for threat actors to get in and hurt things. You want to make sure that RDP connections are torn down when they're inactive and closed off. So keep those two things in mind. Now, let's take a moment to talk about dev test. A lot of us don't have in-house development teams, so we may think, okay, we don't have to worry about this, but that's not necessarily true. Take a moment and think about or investigate, is your company using outsourced or partnerships that are doing development? Are they doing customizations to your business software, right? Are they adding capabilities to your intranet or website that are connecting back into your system? And if they are, you need to look at the techniques that they're using, because a lot of organizations deploy dev test environments and lab environments that will have the capability of connecting back in to portions of their live cloud tenant or their live on-premise infrastructure. And so attackers can essentially use these connections as jump boxes to reverse port from the development environment, from the development resources back into your organization. So let's take a scenario that I've seen, and that's a application development partner had a dev environment that they were using for a customer, and then they had a VPN back into that customer's on-premise environment, and the VM in that dev test was compromised by an attacker, and the attacker began the process of trying to breach back through that VPN. And luckily, the activity was detected as anomalous coming back in on the VPN, and it was stopped before it created any major damage. But you can see it's a real live scene in the field scenario. So now let's take a moment and talk about how you're going to go from where you are today, already overwhelmed, already overworked, already over-provisioned, if you will, against the IT needs of your organization, and deal with this ever-consuming cybersecurity draw that's pulling against you. Well, one of the ways that you can really help yourself is by constantly being ready to report to your leadership, to your executives, boards of directors, your stakeholders, what's going on with cybersecurity, right? Because that's going to garner you support from the top, whether it be support for keeping your budgets where they need to be, or being support for devoting more team members to the cause, if you will, or acquiring more team members. But you have to have that data, right? You cannot manage what you cannot measure. You have to have that data in hand and be ready to report it any time you have the opportunity. Because you may not, and actually it's ineffective now, if you just wait for leadership to ask you to give an annual report or something like that. That's not the way cybersecurity moves right now, right? That's kind of like being a turtle in a race full of rabbits. And I know the old story is slow and steady wins the race, but when it comes to cybersecurity, it's agile and steady. So you need to be steady, you need to have a calm response, but you also have to be very agile and move very quickly when things happen. So let's talk about ransomware specifically, because ransomware is the malware that everyone fears, right? The other malware still exists, and it's still out there. And you may not hear about it as often, but it's still doing its thing, right? It's still compromising systems and sending spam through systems that weren't sent to send spam, and creating pop-ups and all those kind of things. But that isn't the one that really we're all spending our time fending off and shoring up our resources against. That's ransomware. And I still run into some organizations, particularly with leadership that's been in place for a long time prior to this and that sort of thing, where they think ransomware is something that only happens to huge companies or governments or that kind of thing. It doesn't. It happens to everyone. In fact, I live in one of the smallest population counties in Ohio, and in this county alone, in 2021, there have been 4 shutdown level ransomware events. So these are organizations that have been shut down and taken out of business, if you will, by ransomware for some period of time. And they span the range from government entity to commercial business to healthcare. And let's talk about the healthcare impact, because this is a real scenario. I'm giving you from experience. The ransomware shut down the hospital's ability to access any of the data in their systems. So they had no ability to connect to lab data. They had no ability to connect to medical records. They had nothing. So they couldn't safely perform surgeries. So now your loved one was brought in through the emergency room and was scheduled for rapid surgery, so emergency surgery, whatever you want to call it, because they had an appendix that was rupturing. Now imagine that hospital can't do surgeries because they can't do lab work, they can't do any of those things, and your loved one now has to wait to be transported by helicopter or ambulance to a hospital that's an hour away. That's one of those real-world, personally destructive scenarios I told you about cybersecurity, right? And it's a reason why, again, we have to pitch a shutout. You just can't have a ransomware infection. And so what I need you to keep in mind right from the get-go is just because you're putting your resources in the cloud doesn't protect you from ransomware, right? It isn't, okay, well, I just put it up in AWS, so it's infinitely safer because AWS has loads of money that they spend on defense and everything else. That's not enough. You still have to take actions to protect your things. And you can't just do pen tests annually anymore. That's not enough. You need to be doing vulnerability assessments in almost real time. And that's where things like Defender Security Center, Azure Security Center, those things come into play to help you, because they will be doing proactive vulnerability assessments every second almost, if you will. But you need to be leveraging those things and then taking some specific actions on your own part to test and make sure that your defenses are protecting you in the way that you think they are. And do those things at least monthly. So have 12 of them on your schedule for the next year, at bare minimum, if not more. And so let's talk about what that looks like. A lot of us have heard of the expression red team versus blue team. I'm going to invent a new one. A good friend and peer of mine, Dave Kula, we do a lot of these events together, and we kind of co-invented this recently as we were talking about this summit and the things that were coming up. And that's the concept of cloud teams. And so red team is typically the offensive team. Blue team is the defensive team. And that means that the red team folks are well-versed in attacking systems, whether they be attacking endpoints or attacking firewalls, network infrastructure, server OSs, whatever. They're well-versed in attack mode. And blue team is well-versed in the opposite, defense mode, defending firewalls, switches, server OSs, endpoints, okay? But the reason we need to throw cloud teaming into this is because now with our hybrid cloud and our multi-cloud, we have to have specialists that are like the blue team, but focused on those cloud-based, cloud-born resources, right? Let's look at identity management. And so you have a completely synchronized or federated cloud environment where you have your on-prem identity management. We use the example of Active Directory, and you have it synchronized or federated with the cloud. And we'll say, in this case, Azure. So we have AD Connect in place, and we're totally synchronized with Azure Active Directory up in the cloud. You need to make sure that you're protecting both ends of that, because now an attacker could come in from either direction. So that on-premise AD expert that you have that's part of the blue team may not have the background and the education and the experiences necessary to really protect that Azure AD. So you want those people that are on your Azure AD expertise team to be part of the cloud team that goes in here. So now you're going to have red team, blue team, and cloud team. And, make it fun. You don't have to make it super serious or whatever. Make it fun so that your teammates, your IT pros that are working with you, see this as something to look forward to. Because when you do that, the frequency of your cyber defense tests will go up, and their success will go up. So keep that in mind. Now, let's talk about kind of what happens when you go through a ransomware incident. Basically, and I don't know why I always start things on Monday, but I do. So we'll say that on Monday morning, a user walks in and they fire up their computer and they can't do anything. There's just a message, a dialog box up on the screen that says, hey, your computer has been fully encrypted. If you want to get your data back, here's what you have to do. And they're like, oh, no, and they call IT. Well, IT's phones are ringing off the hook because it isn't just this user. It's every user. And IT logs on to the server and say it's an RDSH host, and it gets the same message. And then they're like, okay, and they start checking other servers. And they look at their Active Directory server, and it's got the same message. And then they use Hyper-V, so they log on to the Hyper-V host server, and it's got the same message. What do we do now? When we start making calls, right? Because we've got to tell the company that basically it can't do business, and we've got to tell the cyber insurance company what to do. We got to involve them. We got to understand who's gonna pay for what. And then not only do we look at it and we go, okay, and have the discussion of, should we pay them to get the recovery key? What are the odds that they actually will deliver? What are the odds that the recovery key alone will help us? Because I've been involved in numerous remediations where the recovery key gave back access to the data, but the applications that ran it were still corrupted. So you had to reinstall, you had to reattach the data to the application, you had to do all these things. So this is a big, long process. And one thing that a lot of people don't think of is there are situations where you may not be able to even pay if you wanted to. Because if some of these organizations, for instance, end up on the United States terrorist watch list as organizations that support terrorism, you would be breaking the law by giving them money, okay, because they're now on a blacklist. So now you have to rebuild everything from scratch. And if you're down for weeks or months, who's going to cover the costs of that? Who's going to pay all the wages of the employees while they're working on that and offset the lost revenue and deal with the customers who you're no longer providing your products to and deal with the vendors who you can't issue normal POs and purchasing and that kind of thing too, right? Think that through. This is a big, convoluted process that is kicked off by a very simple event of somebody coming in and turning on their computer and getting a note. So we are in far better shape if we pitch that shutout than if we have to deal with this. And I went out and I got some infographics for you. These are from multiple sources. Of course, you see the one from KnowBe4, but then there's also from Statista and some FBI cybersecurity report information in here and such that just shows you kind of recent numbers related to ransomware. The numbers are huge. So this is real. You may be able to see your area, whether it be healthcare, whether it be retail, whatever in there. None of those areas have less than 25% as far as who's paid a ransomware infection, right? And these are just organizations that are willing to report it. There's a lot that aren't and all that sort of thing. So if this doesn't motivate us to step up our cybersecurity game, I don't know what will. And on that note, David, I'm going to throw it back to you and see if we can talk about a couple of the questions that I see have come in.
You bet. Great job, John. Sorry about that echo. I'll try to get rid of that. Not working. Here's a question. Well, I've got this echo. Are you hearing that, John?
Just a little. It's not bad. I can go ahead and go through the questions if you don't mind, if you've got that going on the end.
Yeah, that's what I was going to suggest. This echo is smart. Thank you.
Okay, so Edgar from Wilkins Manufacturing has thrown out a great question, and he says that leadership there is very old school. And so they don't necessarily see the value in investing more in cybersecurity and those kind of things, and wonders if there's a simple way to demonstrate the importance of a proper network config versus just backups. And now he asked for a link, and I don't have one off the top of my head, but I can tell you some strategies. And one of them is in infographics, and for instance, this last slide. And that's to show them in a visual mechanism the percentage of companies that are spending money to remediate ransomware when versus the companies that are spending money to remediate ransomware and how much they're spending versus those that haven't. And because the number is staggering, as you can see in here. If you look at just the number that is paid ransom, and again, not everybody admits to paying the ransom or being infected or anything else, it shows you how huge the problem is. And most leadership, even old school leadership, will understand that prevention is far cheaper than curing it after the fact. Now, backups are key to your success, but there is a lot of great data out there that shows that most ransomware exists in an organization for 45 days or more, meaning that ransomware has ample opportunity to corrupt your backups beyond your long-term backup storage. And besides that, let's say that they only corrupt 30 days worth of backups and you have 60 days worth. How much will it cost your organization to rebuild that lost 30 days worth of data because you couldn't get it back because the backups were corrupted, right? Pose those questions. Great question. Thank you. And now...
Okay, that's actually all the time we have, John.
Okay.
So thank you again for that presentation and answering that question.